Hello and welcome to the Walking Talking topic on bounds and estimations, question number 4 with me, Mr. Barton. Right, what's going on here? We've got the length of a corridor wall is 68 metres, correct to the nearest metre. We've got decorative wall tiles, each have a length of 36 centimetres, correct to the nearest centimetre. A decorator is brought in here and he's given the job of fitting one single row of these tiles lengthwise, side by side, along the top wall of the whole corridor. Showing all your calculations, find the least possible number of tiles and the greatest possible number of tiles. Okay, well, as soon as we see things that have been rounded to the nearest metre and we see greatest and least, it's got to be a bounds question. So let's start off by working out what are the upper and lower bounds of our two things we've been told. So let's take the corridor first. Corridor. Okay, so it is 68 metres and that's been rounded to the nearest metre. So what's the biggest that could be? Well, I think it's 68.5, because any bigger than that and you're going to go up to 69. What's the smallest it could be? 67.5. Any smaller than that, you're going to go down to 67. Now, the only slight problem is the wall tiles are in centimetres, so I think I'm going to take this opportunity to convert those to centimetres as well, just so we have it in the same units. I could convert the tiles to centimetres, but I don't want to get into all decimals and all that. So, in every metre, there are 100 centimetres. So if I want to know how many centimetres there are in 68.5 metres, I think I'm going to have to times it. So 68.5, and I'm going to have to times it by 100. Now, if my maths is right, I'm going to, and some people don't like this, move the decimal place 1 to the right, and then 1 further, and fill my gap in with a 0. That's 6,850 centimetres, and that is going to be my upper bound. Likewise, 6,750 centimetres is going to be my lower bound. So that's me sorted for my corridor. What about my tiles? My tiles are a bit easier because they're in centimetres, so that's going to be 36 centimetres to the nearest centimetre. How high can we go? 36.5. How low can we go? 35.5. So now all we've got to do is switch on to think how are we going to find the greatest and how are we going to find the least. Well, we talked about this in previous videos. When you're dividing, if you want to make your answer as big as possible, you want something big on top and something small on the bottom. Think about it if you're sharing a cake. You want a massive cake and you want to share it between the fewest amount of people possible if you want a big slab of that cake. So what's our upper bound if we're working out how many possible tiles? Well, we want to get this the right way around. So we've got to make sure that we get either the corridor or the number of tiles the right way. So let's think this through. Well, the corridor, the longest the corridor could possibly be is 6,850 centimetres. And the shortest each one of our tiles could possibly be is 35.5 centimetres. And that's going to give us the most possible tiles we could ever possibly have. So that's 6,850 divided by 35.5, and that's going to give me, SD button that, 192.957 blah blah blah. Well, if we need 192 tiles, that's not going to quite cover it, so we're going to need 193 tiles as our kind of worst case scenario. But what about our least? If you want something as small as possible, and you're doing a division, you want the smallest divided by something really big. So what's the shortest our corridor can be? 6,750. What's the longest one of our tiles could be? That's going to be 36.5. And if we divide those together, so we get 6,750 divided by 36.5, we get 184.931. And therefore, if we think what's that going to be, well, 184.9, we're going to need that extra tile, so 185 tiles. So the least tiles is 185, the greatest tiles is 193.